Alright, so welcome for this weekend's calc video. We're going to finish up target 4. Remember, target 4 was on asymptotes, both analytically and graphically, and both vertical and horizontal. If you remember the vertical asymptotes, basically what makes the denominator 0, and we use the limit definition right here as support for that. And then horizontal asymptotes, that was where we let the limit, take the limit as x approaches infinity, and we'll get our horizontal asymptotes. We did a graphical representation when there was a radical involved, and then we did some rational functions. We came up with these rules, or we saw that these rules, where if the degree of the top is less than the bottom, your horizontal asymptote is y equals 0. If the degrees are equal, you divide the lead coefficients, and if the degree of the top is greater than the degree of the bottom, there's no horizontal asymptote. We did some practice problems for all of this, and then we got into logistic function, where there's an exponent involved. Show that f of x equals 1 over 1 plus e to the negative x has different horizontal asymptotes to the left and to the right. So we'll start doing the basic to the right. So we'll do the limit as x approaches infinity of 1 over 1 plus e to the negative x. Now if we think of this graphically, e to the negative x will go down instead of up. And as we go to infinity on this value goes to 0. So we got 1 over 1 plus 0, which is 1. So to the right, this graph approaches y equals 1. If we're going to the left, the limit as x approaches negative infinity, 1 over 1 plus e to the negative x. All right. Going to negative infinity, okay, we get 1 over 1 plus infinity. That's kind of indeterminate. So what we'll do is we'll kind of use that trick where we divide 1 over e to the negative x, top and bottom. So we got the limit as x approaches negative infinity, 1 over e to the negative x, and then 1 over e to the negative x plus 1. Alright, so we said as this one goes to negative infinity, this approaches infinity. 1 over infinity approaches 0 over 0 plus 1, which is 0 over 1, which is 0. So the right asymptote is y equals 1, and the left is y equals 0. Looking at the next one, this is a little story problem. Let f of t measure the level of oxygen in a pond. F of t equals 1 is the normal unpolluted level. So that means 100% of the oxygen that needs to be there. When t equals 0, organic waste is dumped into the pond, and it oxidizes the level of oxygen in the pond. What percent of the normal level exists in the pond after 1 week? After 2 weeks? After 10 weeks, what is the limit as t approaches infinity? Well, quite simply, after 1 week, we'll plug in 1. F of 1 equals, and this is a good one to do on the calculator. So let's open our graphing calculator here. While you're waiting for it to open, put the function into the calculator. Practice doing that. I will show you how to do it on the Inspire. Most of you don't have that, so get it into y1. Alright, so we'll type that function in. We got t squared minus t plus 1 in the numerator, t squared plus 1 in the denominator, and we're going to store that in f of t. And they already said that a f of 0 is 101 is the normal unpolluted level. And then we want to see what is it at f of 1. So we'll plug and chug f of 1. At f of 1, it's half the normal level of oxygen. F of 1 is 1/2, or 50% of the normal level. What is f of 2? So we'll do f of 2. We get 3/5, which is 60%. So f of 2 is 60% after 10 weeks. Is 91 over 101, which we're about 90%. So after 10 weeks, f of 10, it's 90% of the normal level of oxygen. What is the limit as t approaches infinity? So what does the level of oxygen approach? So we'll do that. Limit as t approaches infinity. Take a look at the kind of function we got there. It is a rational function. And so we use our rules. Here's our power, 2 and 2. They're equal, so we divide the coefficients. So over time, it will approach pre-polluted levels. In other words, it'll approach 100%. Will it actually get there? Debatable. Okay? Now this one. This one's a tricky one because that radical's involved. Now, straight up, if we go to infinity, look at the powers if it's positive infinity. Right, if we look at the powers, positive infinity, here we got the square root of x squared, which is a power of 1. Here we got a power of 1. Right? Powers are the same, so we divide the coefficients. The coefficient on the top is the square root of 1. The coefficient on the bottom is 2. So this is 1/2. Now, if we go to negative infinity, slightly different. Alright? So if we go to negative infinity, again, we'll look at the powers. This is a power of 1 because it's the square root of x squared. This is a power of 1. But if we look at it, is this value going to negative infinity? Because you're squaring it. So that value is not actually going to negative infinity. That value is going to infinity. So the top will take the coefficient, but on the bottom, in order to make it to go negative infinity, whatever you have there, you need to negate. So the bottom will need to be negative square root of 1, and that simplifies to negative 1. And that's the trick with the radicals. Because the negative infinity, when you have this squared there, it cancels out the negative. So this is really going to infinity. So we need to negate it to get it go back to negative infinity. All right. Finally, right here, sine limit as x approaches infinity is sine of 2x over x. The top, sine as we get closer and closer to infinity, it just kind of goes back and forth between negative 1 and 1. So that will be a number divided by, and as x approaches infinity, when we take a number and break it into infinite pieces, we approach 0. So this one approaches 0. So as you do these asymptotes, these limits at infinity, we need to just think about looking at the situation, seeing what's happening with our infinity. Which way are we going? So review for this target, the big ideas I wanted you to get were the vertical asymptotes. Vertical asymptotes, what makes the bottom 0? specifically looking at the limit definition. So make sure you see as x approaches a number, the limit increases or decreases without bounds. For the horizontal asymptote, you're going to take the limit as x approaches infinity and x approaches negative infinity. That's very important. You get the negative in there as well, because for radicals and exponentials, logistics, it's different. For rationals, you're fine, but for radicals and exponentials or logistics, you need to do both because left and right are different infinities.